Hello everyone. So we are going to see Module 1 Understanding Linux Concepts. So what is Linux? Linux is an operating system which sits in the middle of your hardware and users. Unix versus Linux. Unix was first developed for multi-user and multitasking in mid-1970 in Bell Labs by ATT, GE and Massachusetts Institute of Technology. Then born Linux is 1991 by Linus Torvalds. Linux is mostly free, it is an open source, it is mostly used by Sun as Solaris, HPUX, AIX, etc. It is used by many developers, community or companies. It is comparatively supports very fewer file systems. It can be installed on a wide variety of computer hardware ranging from mobile phones, tablets, video game consoles to mainframes and supercomputers. 114 Linux commands. So Linux, the price is free. The Windows, it costs some money. It is not user friendly and Windows is user friendly. Reliability. Linux is very reliable and Windows often requires a reboot. Software. Mostly enterprise level softwares. But Windows, much larger selection of softwares, example Office, games, utilities. Multitasking. Linux is best for multitasking. Windows, multitasking is available but with very high CPU or memory resources. Security. Linux is very secure, but Windows somewhat secure. Open source, open to public. Windows not an open source OS. And these are the Linux distributions: the Red Hat, CentOS, Fedora, SUSE, Debian, and Ubuntu. So the Linux users, US government and agencies, NASA, healthcare, the bullet trains in Japan runs at speed of 150 to 215 meter per hour, traffic control, financial institutes, and etc. So next we are going to see the history of Unix on Linux. In 1965, Bell Laboratories joined with MIT and General Electric in the development effort for the new operating system Multics, which would provide multi-user, multi-processor, and multi-level file system among its many forward-looking features. In 1969, AT&T was unhappy with progress and drops out of the Multics project. Some of the Bell Labs programmers who had worked on this project, Ken Thompson, Dennis Ritchie, Rutt Kennedy, and Doug McClory, designed and implemented the first version of Unix file system on a PDP-7 along with a few utilities. It was given the name Unix by Brian Kernighan as a pun on Multics. In 1971, the system now runs on a PDP-11 with 16 kbytes of memory, including 8 kbytes for user programs and a 512 byte disk. So, its first real use is a text processing tool for the patent department at Bell Labs. Unix caught on among programmers because it was designed with these features. Programmer's environment, simple user interface, simple utilities that can be combined, hierarchical file system, multi-user, multi-processor system, architecture independent and transparent to the user. And in 1984, there are now about 100,000 Unix sites running on many different hardware platforms. In 1988, AT&T and Sun Microsystem jointly developed System V Release 4, SVR4. And in 1993, Novell buys Unix from AT&T. In 1994, Novell gives the name Unix to X/Open. 1995, Santa Cruz Operation buys Unixware from Novell. Santa Cruz Operations and Hewlett-Packard announced that they will jointly develop a 64-bit version of Unix. In 1996, International Data Corporation forecast that in 1997 there will be 3 million Unix systems shipped worldwide. And next we are going to see what is inside Linux, the kernel. The core of the Unix system loaded at the system startup, memory resident control program. It manages the entire resource of the system, presenting them to you and every other user as a coherent system. Provides service to user applications such as device management, process scheduling, etc. You do not need to know anything about the kernel in order to use a Unix system. These details are provided for your information only. Shell. Whenever you are logging into a Unix system, you are placed in a shell program. The shell's prompt is usually visible at the cursor's position on your screen. To get your work done, you enter commands at this prompts. Several shells are usually available on a Unix system, each with its own strengths and weaknesses. Different users may use different shells. Initially, a system administrator will supply a different shell, which can be overridden or changed. The most commonly available shells are Bourne shell, C shell, Corn shell, TC shell, Bourne again shell. And each shell also includes its own programming language. Command files called shell scripts are used to accomplish a series of tasks. And utilities. Unix provides several hundred utility programs, often referred to as commands. Accomplish universal functions like editing, file maintenance, printing, sorting, programming support, online info, etc. Modular, single functions can be grouped to perform more complex tasks. And next we are going to see the operating system. An operating system or OS is a software program that enables the computer hardware to communicate and operate with the computer software. Without a computer operating system, a computer and software programs would be useless. So, it performs these services for application. In a multitasking operating system where multiple programs can be running at the same time, the operating system determines which applications should run in what order and how much time should be allowed for each application before giving another application a turn. It sends message to each application or interactive user about the status of operation and any errors that may have occurred. It can offload the management of what are called batch jobs so that the initiating application is freed from this work. On computers that can provide parallel processing, an operating system can manage how to divide the program so that it runs on more than one processor at a time. So we are going to see the examples of computer operating systems. The first one is Red Hat, Microsoft Windows, Apple Mac OS, Ubuntu Linux, Google Android, iOS. So these are the examples of computer OS. And next we're going to see the various parts of OS. Unix and Unix-like operating system consist of kernel and some system programs. There are also application programs for doing work. The kernel is the heart of the operating system, and it is often mistakenly considered to be the operating system itself, but it is not. An operating system provides many more services than a plain kernel. The system program uses the tools provided by the kernel to implement the various services required from an operating system. System programs and all other programs run on top of the kernel in what it is called the user mode. The difference between system and application program is the one of intent. Applications are intended for getting useful things done. A word processor is an application mount is a system program. The difference is often somewhat blurry, however, and is important only to compulsive categorizers. And now we're going to see the important parts of the kernel. Process management, memory management, hardware device drivers, file system drivers, network management, various other bits and pieces. So, the following figure shows some of the most important parts of the Linux kernel. The user level programs, systems all interface, virtual file system management, the memory management, process manager, and abstract network services, TCP or IP protocol drivers, Ethernet card driver, and Ethernet, and various file system drivers such as IDE hard disk driver, floppy disk driver. So, probably the most important parts of the kernel are memory management and process management. So at the lowest level, the kernel contains a hardware device driver for each kind of hardware it supports. Since the world is full of different kinds of hardware, the number of hardware device drivers is large. The similarities make it possible to have a general class of drivers that support similar operations. Each member of the class has the same interface to the rest of the kernel but differs in what it needs to do to implement them. They all have operations like initialize the drive, read sector in, and write sector in. And the last one is virtual memory. Linux supports virtual memory that is using a disk is an extension of RAM so that the effective size of the usable memory grows correspondingly. Linux can use either a normal file in the file system or a separate partition for swap space. A swap partition is faster, but it is easier to change the size of swap file. When you know how much swap space you need, you should go for the swap partition. But if you are uncertain, you can use a swap file first, use the system for a while, so that you can get a feel for how much swap you need, and then make a swap partition when you're confident about its size. A note on operating system terminology: computer science usually distinguishes between swapping and paging. Paging is usually more efficient, that's what a Linux does, but traditional Linux terminology talks about swapping anyway. Thank you.